All right, today we're diving into something that feels like a high-tech showdown. It's basically an AI duel, where we're pitting a bunch of different machine learning models against each other. And the prize? It's the ability to predict dengue fever. This is some seriously high-stakes stuff, so let's see who the champion is. And really, it all boils down to this one crucial question. Can an algorithm, just lines of code, actually predict a deadly disease before it's too late? I mean, we're not just geeking out about data here. We're talking about a tool that could literally get ahead of a dangerous illness and save lives. The implications are huge. So, why is this so critical? Well, the title here says it all. It's a ticking clock. To really get why this research matters so much, you have to look at a place like Bangladesh. Every year, seasonal dengue epidemics hit, and they can totally overwhelm the healthcare system. So having a reliable, early warning system, it's not just some cool tech feature. It's an absolute necessity. Just think about it for a second. If a doctor can use this tool to predict who's likely to have dengue just based on some early data, that's a game changer. They can manage their patients better, they can allocate hospital beds and medicine more effectively, and, this is the big one, they might even stop a small outbreak from becoming a massive one. The stakes couldn't be higher. Okay, so how did the researchers figure this out? Well, they did what any good scientist would do. They set up a competition. A showdown, you could say. They basically threw 6 different machine learning models into the ring to see which one was the undisputed champion for this specific job. And here they are, the 6 contenders. It's a pretty diverse lineup, covering a whole range of AI strategies. You've got your classics, like the decision tree. You've got a statistical model, the Gaussian naive Bayes. There's even an artificial neural network, which is kind of inspired by the human brain. And then you have the heavy hitters, the so-called ensemble methods, Random Forest, XGBoost, and AdaBoost. These guys are gonna be important, so keep an eye on them. So, what's the deal with those ensemble methods I just mentioned? Well, the core idea is actually super simple. Teamwork makes the dream work. Seriously, instead of relying on one single model to make the call, an ensemble method gets a whole bunch of smaller, weaker models to work together. It's like asking a whole committee of experts instead of just one. By combining all their opinions, you get a final answer that's way more accurate and reliable. It's teamwork, but for AI. Now, any good competition needs a fair playing field, right? A proving ground. So to really push these AIs to their limits, the researchers didn't just use one set of data. Nope. They set up 2 different rounds with 2 different datasets to see how the models would perform under different conditions. Okay, so here's the setup. For round 1, they used what they called the real dataset. This is exactly what it sounds like. Real-world clinical records from patients in Bangladesh. It's authentic for sure, but there wasn't a ton of it. Then for round 2, things get interesting. They created an extended dataset. They took that real data and basically bulked it up with synthetically generated data. The goal was to give the AI a much bigger, richer textbook to learn from, which leads to the big question, right? Does having more data, even if some of it is fake, actually lead to better predictions? All right, the moment of truth. The models have been trained, the tests are done, the showdown is over. It is time to find out who won. Let's unveil the results. So let's start with round 1, using just that smaller, real-world dataset. And honestly, the results are already pretty good. You can see that the top models, those ensemble methods we talked about, Random Forest, AdaBoost, and XGBoost, they're all clustered right up at the top. We're talking around 97% accuracy. That's a really strong start. But, it's not perfect. There's still a little wiggle room for mistakes. But then, check this out. This is round 2. And wow, this just goes to show you the incredible power of having good data. The moment they trained the models on that bigger, extended dataset, the performance of every single one shot up. Look at that jump. The difference is night and day. It's just so clear. And the champion, the absolute best performer, hit a peak accuracy of 98.5%. That is an amazing result. But who was it? Which model managed to pull that off? And how did everyone else do in comparison? This table tells the whole story. You can see it right there at the top. The winner with that incredible 98.5% score was the Random Forest Classifier. But what's really fascinating is if you look down that right-hand column, XGBoost was hot on its heels for sure, but notice how every single model's accuracy went up. This is the proof. It shows that it wasn't just about having the fanciest algorithm. It was about giving that algorithm the best possible fuel to run on. Okay, but hold on. Especially in medicine, a high accuracy score doesn't tell you everything. It's not just about how often the AI is right, it's also about the kind of mistakes it makes when it's wrong. And to figure that out, we use something called a confusion matrix. It's just a fancy name for a scorecard, really. It shows us exactly where the AI got things right and where it messed up. And out of all the possible mistakes, there's one that is way, way more dangerous than any other. It's called a false negative. That's when the model looks at a patient who actually has dengue and says, nope, you're fine. As the paper itself points out, this is the single most critical error you can make. Imagine being sent home thinking you're healthy when you actually need urgent care. So avoiding that specific error is absolutely the #1 priority. So, after all that, what if we learned? When you put all the pieces together, why did our champion win? Well, the subtitle here says it all. It's not just about the algorithm, it's about the data. The final analysis really boils down to a few very clear, very powerful takeaways. So let's break it down into 3 simple takeaways. First, the top contenders were clear. Random Forest and XGBoost consistently performed better than everyone else. Second, and maybe this is the most important lesson of all, data is king. That bigger, beefed-up dataset made every single model perform better, no exceptions. And third, teamwork wins. Remember those ensemble methods, the ones that act like a committee? They proved to be way more powerful and trustworthy for a complex job like this. So, at the end of the day, the conclusion from this whole experiment is crystal clear. You take the winning algorithm, Random Forest, and you train it on the best possible data, that extended dataset. That combination is what gives you the most promising path toward a reliable and potentially life-saving dengue prediction tool. And that really leaves us with one last big question to think about. We've just seen AI predict one disease with incredible accuracy. So, what's next? What other medical mysteries could we solve if we apply this same formula? Smart algorithms combined with really, really good data. When you start to think about it, the possibilities are just incredible.